Okay, the purpose of this hopefully short video is to give a bit of a tour of the Protection Range Estimator software, just how to use it. So if I double click on the executable file, the software starts to run. For some reason, I don't know why, occasionally this form appears. So ignore it, just click close. It's a warning that one of the threats is outside the spectrum analyzer band, but it's warning about threat 2, which is not included in this analysis. So here is the startup form. The main part to be interested in is this radio group at the top, where you have a choice between the engineering development interface and the hardware demo interface. And if we choose this one and click proceed, then up comes the engineering development form. And if we choose the opposite, the other one, and click proceed, what comes up is another little form that's and then you choose show hardware interface, and it shows the form that has the familiar, the three, traffic light buttons on it. So I'll get to those in a minute, but let's start with the introductory form. This bluish panel allows the user to choose between several sets of pre-recorded spectra that were recorded on open test ranges under different conditions, and the documentation tells you what they all are, so you can play them back and see what happens. There's two radio groups here. One is for configuring the playback data, and right now what's selected is the DRDC spectra recorded at the DRDC test range. It's the same place that was used for the demo on the 22nd of May this year. And as I change these, you can see the various parameters changing over here to show you what the effect of each of these options is. So if we'll return to the demo recordings, there's also a radio group for controlling the threat configuration. And again, it's just configured for the DRDC collinear trigger and ECM. But if we change these, we see these numbers here change as well. So we can see, a summary of what's happening. But I'll leave it in the startup configuration. So we're at the development interface, so we click proceed, and here is the engineering development form. The first thing to notice is this is a big black area in the middle, which is essentially a spectrum analyzer. To see it better, I'll uncheck at the bottom here group box for ECM control, add chirp to spectrum. If I unclick that, we can see the recorded spectra. And here's a range slider. This is a distance from the ECM to the sensor or to the PRE device. So as we move this farther out to 22 meters and 27 meters and so forth, you can see the software going and collecting up the spectra that were recorded at those ranges, all the way out. In this case, we go to 120 meters. So we can do a virtual experiment in software just by calling up pre-recorded spectra. So I'll leave this around 30 meters. Okay, back to the form. Aside from this middle area, put the chirp back in, there's another black form right here, panel, which is the output, a summary of the output of the PRE device. And you can look at all these little things, but here this purplish looking one shows the protection range estimate measured from the ECM, and it's wiggling around, the median value is wiggling around 64, 65 meters. And we'll notice that the sensor right now is at 30 meters, so this little green edit box here for threat 1 is hovering around 30 meters less than the estimate from the ECM, because we're 30 meters away from the ECM, we're 30 meters closer to the protection perimeter. Now, over here, moving to the top left, there's a panel here, a small panel here, that allows you to configure the threat. So if I click this button right here, this tiny little button for configure threats, up comes a form that allows us to configure the threat. You can set the center frequency, transmitter power, receiver antenna gain, transmitter antenna gain, distance between the threat and the transmitter, the threat transmitter and receiver. It's 120 meters right now. The polarization, is that controllable? I believe that at the moment these are not in play. You can change them, but I don't think they have any effect. I'd have to check that. And there are separate controls for the trigger transmitter height. And then there are two separate controls for the height of the receiver antenna, because it could have two different heights. It could have a height relative to the ECM, and it could have a height relative to the threat transmitter. If the ECM were operating on a road bed and the threat is in the ditch, and the trigger is on a tower, then the height of the receiver as seen by the tower might be different than the height of the receiver as seen by the ECM. So, I mean, if you this is for trials primarily in order to represent certain kinds of trials. But if you don't know where the threat is, then put it wherever you want to, where the threat receiver is. And each of these yellow edit boxes is the variability that's associated with each one of those parameters. Now, this is a side bug point. For sometimes I notice that these values don't seem to be applied unless I toggle this checkbox, and it's like it wakes up the software. It is a multi-threaded application, and it wakes it up and says, "Oh, well, let me look at these edit boxes." So the results may change. So it's, if you notice something that's funny, try toggling that checkbox. So I'll close this. Now, oh, by the way, before we go, here is the surface type between the trigger and the IED receiver. So, and there are a bunch of choices: wet asphalt and dry asphalt and wet sand and copper and so forth. So this is the determines the surface reflectivity between the trigger and the IED receiver. So if you happen to be operating your ECM on asphalt, but you know that the trigger man has to be off in the bush somewhere, then this allows you to use a different reflection coefficient for the trigger to the IED receiver compared with the ECM to the IED receiver. So I'll close that. Okay, back to the main form and just sort of working clockwise around. The one thing we can see is there's a display type, a radio group here called display type, and it controls the use of this big black square in the middle. Right now it's in spectrum analyzer mode, but we could go to an isometric view, and this is an isometric view of the area around the operating area around the jammer, and there's some controls for zooming in over here. We can get closer, and we can rotate the view. This is just eye candy, really. Or change the tilt angle, the elevation. There's two buttons, repaint and reset here, which are useful for cleaning up the display. The two red contours represent the inner and outer boundaries of a warning zone, and I'll get to that in a minute. But next thing I want to show is ignore the GA for genetic algorithm part. That's not, I click on it to show you what it looks like, but that's not relevant unless genetic algorithms are in play, which they are not right now. So let's go from isometric view, I'll clean that up, to a road view. Now in the road view, it's as though you're standing at the sensor, at the PRE device, holding your hand and looking outwards. And so there's nothing shown on this black field, but this would be what your eye sees. If a webcam were, for example, active, then it draws these lines superimposes them on the ground you would see from a webcam, and I'm going to show you that in a minute. So if we leave that there for the moment, let's go back to the spectrum analyzer view. And continuing to move around, there's in the operation or in the assessment panel, there's a small button that says large. If you click that, what shows up is a large display panel, an alternate large display panel. So this one has the traffic light display on it, and it's got a radio group across the top that lets you choose from 4 different options. This controls, which allows you to change the heights and distances and so forth if you wanted to without going back to the main form. There's a safety range option, which is just strictly digital, so it shows, it's useful for, I should have used it during the 22nd of May trials. It's a large display, easy for a few people to see. It shows the median protection range from the ECM and also from the sensor, but the more important parts are the ranges, the near edge and far edge, the distance to the near edge and far edge of the warning zone, measured relative to the ECM and measured relative to the sensor. There's a photo view thing which doesn't function. It's not a real function except eye candy. It's just to illustrate someday if we were able to color the ground green, yellow, red, it would look something like this. But what is operating, if I go back to the road view here and invoke the large display and go to webcam, then after the webcam wakes up, what you will see is me. But superimposed on this video image are the warning zone boundaries and the calibration lines that are used to calibrate these lines against the webcam view. So I haven't done it, never implemented it. Well, it is implemented, but I haven't actually done a demonstration of it. You would stick a webcam up and look over the road, and this thing will show you from where you are what you would see if you could put on some magic glasses and actually see the warning zone impressed on the ground. In fact, we should be able to do that. Just let's move forward towards 60 meters. And as we get closer, you can see those red lines getting closer. So we're actually standing closer to the, here they are. Well, the webcam has to wake up again. The yellow lines are, if we could see a road in front of us like this, that's what you would see. Okay, so let's close that.
By the way, I did measure the inverse of this, actually. This is not just talk. The contours do exist, and they can be observed in the real world.
There's several controls over here. This control allows us to adjust the height. Let's go back to the spectrum analyzer view. The height of the ECM antenna. This control adjusts, you've already seen it, the distance between the ECM and the sensor. This control adjusts the height of the sensor antenna. This control adjusts the ECM antenna gain. We can control the ECM power up here. And all these yellow edit boxes are the variabilities associated with each one of these parameters. And there's an ECM control panel down here where we can adjust the center frequency of an FM chirp and adjust its span as well. And there's a noise gate, but that, you can read about it if you want to. Okay, moving back up to the top right here, there's a button. If I click this button here under the propagation panel, a form comes up so that we can configure the propagation model. So here we can choose in this yellow what kind of reflectivity there of the ground, whether it's dry earth or asphalt or copper or absorptive or dry sand or whatever. And there is an option to include a back wall scatterer. And if we click this checkbox, then these controls in this panel now become active. So here we have a distance from the ECM to a reflecting wall, like a fence or something, is 250 meters. We can adjust that like so. And this will be included in the estimation of the ECM antenna, ECM power at the sensor and also at the threat. And you can adjust the cross range position of the fence. Right now it's at 0 meters, but we can move it to the side. And also the surface type, can select the surface type between, the surface type of the back wall scatterer, what its reflective properties are. If it were a fence, you'd choose copper, but we'll uncheck that. And we can also include a second scatterer off to the side. Anyway, this is getting a bit too involved. There's no need to get into all this. You can read about it if you want to. But there's a checkbox here for that as well, if you wanted to enable it or not. So we can close that form. If you want to change the polarization of the jammer, then there's a radio group here, horizontal or vertical. And this affects, by the way, the calculations that are done internal. We have to tell the PRE device, we have to tell the device what our jammer looks like, how it behaves. And so that's what all these controls are for, really. There's a button down here called Show SA Control Panel, Spectrum Analyzer Control Panel. Oh, you know what? Before I do that, this is an important one over here. It's a bit covered up, but there's a label here that says randomization, and this allows you to enable or disable randomization. If it's checked, then all these yellow edit boxes that have variabilities in them, they are now active, and each pass through the main solution loop, as is described in the documentation, each pass generates at present 100 attack scenarios. Although we can change that number with this button here. 100 attack scenarios, and in each scenario, every single parameter that has a yellow edit box associated with it is then assigned a random value equal to the nominal value, and a randomized component that sits within the specified window around the nominal value. Okay, so over to the Spectrum Analyzer Control Panel. This controls where the input comes from, the spectrum input for the device. And right now, we've got this little combo box at the top, and it's showing iCore Robot DRDC Test Range May, should say 2013. But if I click on it, there are a lot of options here. These are all sets of pre-recorded spectra that have been built up over the last few years to allow anybody, me, user, to investigate the effect of this or that using essentially live trials data. If you put your cursor in this field, the background thread is reading this combo box status all the time. So as you highlight different things, it'll start to use them, which is overall fine. But if we move it to the top, you'll notice there's an option for external spectrum analyzer, and that causes problem because it isn't present. So if you get that, just click OK, and it will revert to simulation, which is internally generated option here. Except for it seems to have frozen. No, can't see what's... Oh, probably the thread has gotten lost, I think. Let's see if it restarts in a second. I don't think it's going to, so this is a real demonstration. I'll click close, and we'll restart the software. Okay, there's that. I don't know why that shows up. Just dismiss it. And we'll click proceed, and we're back to where we started. So the Spectrum Analyzer Control Panel, yeah. We'll go back to internally generated. Try not to click the external spectrum analyzer option because it's not present. But here we have now an internally generated spectrum. See, I can clean this up. If you get a bunch of white things, click repaint. And we can adjust the usual things with the spectrum analyzer, the center frequency in megahertz. You know, if I change it, you can see it changing. The center frequency up to 910, 915 megahertz. Can change the span from 60 megahertz to something smaller. And the reference level up or down. This case may be. And the dynamic range is at 10 dB per division, but we can change it to 5. I don't know why we would want to, but sometimes during trials it's useful. Okay, so let's go back to, well, we can leave this alone, actually. No, let's go back to replaying trials data from the DRDC test range. Close, and okay, there we are. Now let's go back to the introductory form, and instead of looking at the hardware or engineering development form, we'll go to the hardware demo interface, and if we click proceed, we get a little panel, and then if I click show interface, here come the traffic lights. And now if I click show level bar, now why do we have no protection suddenly? I think it has forgotten to look at the threat, so let's bring up the threat form. Yeah, toggle that because we restarted the software. Now we're getting numbers that look more familiar from the trial. You know, something like, I'll move this out to 30 meters. Yeah, numbers like protection, median protection range around something like 63, 64 meters, and variability on that. So here, back to the so-called trials form, when I click show level bar, a level bar appears on the right side, and this is graduated in meters. It shows distance from the ECM, which is at the bottom, outward. And the ground is divided into green, yellow, and red areas for operational warning and danger. And this red marker right here shows the current position at 30 meters of the sensor. It's how far you've walked away or driven away from the ECM. Now this distance here is controlled by this form, this control, their distance control right here on the main form, but it's also controlled by this one on the top. So as I move this, you can see over here, that slider on the engineering development form changes, and so does the position of the little arrow marker on the group block or level bar. And if I move it far enough away, we go through the warning zone and into the red zone. So I'll move it back. On the right side is a confidence slider. So right now it's set at 60%. And if we increase the confidence, let's say to 95%, notice that the yellow warning zone gets wider. Now, the connection between the yellow warning zone and the probability density function, there's a PDF graph down here, a live one. If I click on it one time, it appears. If I click on it again, it goes away. And it shows the probability density function, which is developed by the software, considering many, many, many hundreds or thousands of possible attack scenarios, where we would expect to see the ECM effectiveness toggle range. And as I notice these two dotted lines that show, they indicate the inner and outer boundary of the warning zone. And they're labeled down here, 60 meters and 78 meters or whatever it is. And the same labels appear on the level bar. So as I change the confidence level, you can see those lines move closer together because they're enclosing now, in this case, 20% of the area under the PDF. That's the sense of what's going on here. There's also an option to see, for convenience, the spectrum in this window. If I remove the chirp, you'll see, first of all, the protection range goes down to 0, or nearly 0, because it thinks that this is how much power there is. There's no chirp, there's only a little single tone. So if I go back and add this 1 megahertz wide, tell it there's a 1 megahertz wide spectrum present, then that's what you see. If you click on this, it goes away. There is the option for 2 lights or 3 lights. I thought that was interesting. If you watch, well, let's get the confidence up to 95%. So it's interesting to see what happens if you take away the level bar and you move outwards. There's no warning. As soon as you're sort of going from operational to danger. And just to highlight what the meaning of the way it's wired up right now, once the position of the operator moves even to the inner edge of the warning zone, the device says, well, no, you're in a danger condition, unless you have 3 lights, in which case it tells you there's a middle ground where we're not sure whether the device would, an ID would go off or not. So this basically gives you an idea of hopefully gives you an idea of what's happening. There's another mode for this. There are 3 modes for this so-called trials interface. This is the extended mode where it tries to estimate, the device is trying to estimate where the warning zone is relative to the ECM system. But there's another simpler mode called a local mode where it's really just a power measurement at the device, a threshold type thing. So now this level bar, instead of being distance, because we don't know how far we are from the ECM, it's strictly a power level thing. The power level calculation are done using the threat intel and the configuration that we've set up for the threat. And it's using the measured ECM power in situ where it is right now. And it's computing, the warning zone is now translated into a range of power levels, ECM power levels, where you're standing right now. So there's no attempt to get a sort of a field view, an area view, what's happening in the general vicinity of the jammer. Instead, this mode is strictly concerned with what's happening to me. And then in this edit box, or excuse me, radio group, there's another option for a webcam view, if I can get it to click. It took 2 tries, by the way. So this will wake up the webcam again. Should do. It will in a second. There we are. Me again. And if we were go back to the engineering form and click on the road view, then now we see these lines appearing on the display, which this would normally be showing like a view of the road in front of you. I don't know if it would be a useful thing to have or not, but it does. It's a real visualization. That line is over by that tree, and the inside one is over by that rock. So let's orient ourselves and not go past the rock, kind of thing. And if we go back to the isometric view, then those lines are no longer calculated or developed, so they disappear from the display. So let's go back to the extended mode. The extended mode corresponds to this mode, the area, or where we're looking at an area around the jammer, trying to estimate, distances and so forth. Okay, have I covered everything? I think that I have. Trials form show level bar, PDF confidence slider, yes. Propagation model, yes. We talked about the spectrum analyzer control panel. By the way, the spectrum analyzer control panel is only visible if you're looking at the spectrum analyzer. So if you're looking at the thing trying to figure out where that went, it's a little bit context sensitive. There is one other thing to mention. When the software is running, you can observe its behavior, but if you ever wanted to look at things after, like what it has done, a record of what it has done or is doing after the fact, and you need to save data and be able to graph it. So there are some save data controls there I'll mention. In the top left here, we have a checkbox called Enable Main Loop Recording. And when this checkbox is checked, for the duration that it's checked, various parameters are recorded in an external data file after each pass through the main solution loop. And there's a small question mark beside this. If we click on that, a dialog box comes up that shows the name of the data file that is produced and definition of what all are in all the columns, and over here the name of the MATLAB file that you can use to graph this data. So I'll just click Enable Main Loop Recording, and you can see a recording light turns on over here and a count of the number of main loop passes that have occurred since the checkbox was checked. If you wanted to see data for 100 passes, wait till that number gets to 100 and then uncheck the checkbox. And each time a data file is saved, the software throws up a dialog box that explains what file was just saved, and generally speaking, or in every case, how to graph it. Over here, there's another recording control. There's a question mark here. I'm not sure what that's for. Let's click it and see. Well, a dialog box comes up, which you can read in slow time. There's another recording control here. We'll click on the question mark beside it. Now, the purpose of this control, there's a record and a stop button here, is to record parameter assignments during randomization. And this is for recording parameters that are set inside in a single pass, within a single pass of the main loop. Each time the main solution loop is executed, if you look over here, you'll see a population edit box. It's right now set at 100. Each time the main loop is executed, and that is every time this display flickers is a single and is updated. That's a single pass. Each pass through, there are 100 randomized attack scenarios are generated, where the randomization has to do with these yellow boxes. And we can change this number. Oh, by the way, as it runs, each main loop pass contributes, in this case, 100 attack scenarios to a population whose upper limit, in this case, is 1,000. I can't remember why, but I set it at that. So by setting this number to different values, it allows the software to give an answer before it's generated all of 1,000 scenarios. So if we change this number from 100 to a 10, the software runs faster. You can see the flicker speeds up. And if we change it to a bigger number, like 500, whoops, 1500, let's change it to 500, then it runs more slowly. And there's a spin button to set different values. We'll leave it at 100. So if we check this button, check the recording button, the software starts recording randomized parameter assignments within each main loop pass until we click the stop button. And then again, it throws up a dialog box to explain what was just saved and how to graph it. On the bottom right, there's another save. There's a save button and a question mark, another help button. So we click on that. We see by clicking the save button, what we get is a snapshot of the state of the Protection Range Estimator software in these files: polar plots of the ECM antenna gain and the protection range, spectral data, so if it shows you the screen capture of the power versus frequency, the spectral information that the device sees at the moment that the save button is clicked, antenna elevation files, and second-party antenna or third-party antenna elevation arrays. So if we click the save button, then instantly you get a snapshot and you get a dialog box saying what was saved. Now, just to close out, I thought this was interesting. There's a JSR to calculate over an area. If you click this little green panel, another box comes up. And now, to make this work, we have to actually have some ECM present. So I'll add the ECM back in. There's some controls here, and they're explained in the documentation. But if you click the Start Project button, it draws a graph, like a plan view of the protected area, the warning zone, and the danger area, where the IED trigger receiver will be successfully detonated by the trigger signal. And this is a plan view of an area around where the jammer is. So anyway, I thought it's interesting to play with. You can add scatterers and so forth and see how some of these things affect the ECM, the protection area. And that concludes the presentation, the introduction.